Good afternoon, everyone. I'm Xiaolu from Protocol Engineering China team. And today I will give a talk about the SMB client test suite. We also ask Nick and Teron help me to do some demo for this test suite. This is the agenda of this talk. First of all, I will briefly give you an introduce to the SMB protocol and the test suite itself. And then I will talk about the design of the client test suite. SMB client test suite this is the first time we will demonstrate the client test suite on this Plugfest event. So there are some special designs I would like to introduce to you. And finally, I will ask Nick and Teron to do some demo. Okay, so SMB version 1 protocol is an extension of the Common Internet File System protocol, and which extends the following features for the file sharing system, which include the new authentication methods and GSS. And it also provides the enumeration and access to previous version of files. And we also optimize the client request for the server-side data moving operations in this protocol. And SMB connections that use the direct TCP for the SMB transport. We also support for the retrieving extended information for the files. And we also provide some SMB commands for the setting and query quarters from the file system. Okay, next I will talk about the requirements of this client test suite. Typically, we only focus on the client behaviors requirements, which gathered from the technical document. Typically, it's from the common section and the server section, the client section from the technical document. For example, in the section 3, we just collect the requirements from the section 3.1 and 3.2. And in this test suite, we will not verify the requirements for the for the server requirements. And we also don't test the requirements from the CIFS, Common Internet File System protocol. So if you have attended the previous Plugfest events, you should have been familiar with the server test suite. Server test suite typically will the client behaviors of the server test suite is synthetic, and we need to pre-configure the real files and real shares on the system under testing. In the rest of the talk, I will use the term of SAT or SUT, which stands for the system under testing. For the client test suite, there will be some difference to the server test suite. The first aspect is the server behaviors will be synthetic in our test suite, which means our test suite will trigger your implementation to send the request message to our test suite. Then our test suite will simulate some server behaviors and generate response messages to your implementation. The next part will be very interesting because we do not put the real files or shares on the driver computer which our test suite runs. You may find that when your implementation trying to open a file A on the server, which our test suite runs, but our test suite will respond a file B, you don't be surprised. You don't have to worry about that because we just generate some fake file responses for testing purpose. Another important feature of this test suite is the trigger system. We need to trigger the client to send the first request message, and so that we can respond to the following responses message. I will talk about this later. This is the tools our test suite will depend on. You have to verify the 2 versions before you run our test suite, because we only tested our test suite on these specific versions. And if you just run our test suite in our lab, you don't have to worry about that, because we have verified all the 2 versions. The protocol test framework has been packaged into the protocol test suite library installer. So when you install the protocol test suite library, the PDF, the protocol test framework, will be installed as well. Netmon is an optional tool. It's just for debugging purpose. We don't have any version dependence on that. Okay, next session I will talk about the design of this test suite. This test suite adopted the model-based testing. I think Keith Stubbe has already given a talk about the model-based testing yesterday. And for this test suite, we only use the lightweight model-based testing, which means we didn't follow the technical document to generate asynchronized model. We just use the synchronized request and response message, which means we will combine the receiving request message and sending response message into a single method of the protocol adapter. And we also didn't fully implement the abstract data model of the protocol. For example, we didn't simulate the shares, connections, and the sessions or opens. Sorry. Okay, so Keith has already explained the model-based test process, so I will briefly go through the whole process. In the first step for the MBT is to collect the information and the requirements from the protocol, which state in the technical documents. We will abstract the actions and collect the states from the document, and we also generate some restrictions from the document. Then we will use a C# to code them. Then we use the tool, which is Spec Explorer. We use it to create a model. And then we use a tool to generate test cases. The test cases will drive our protocol adapters to do to send the message on the wire or receiving the message on the wire. The lower layer of the test suite is transport. Currently, we we use the protocol test suite library, and we use the functions for the SMB and sieves. After all the test cases generated, and we can just combine them into binaries. So we will ship those test cases binaries in the test suite package. And the binaries can be used directly to run against the implementations. Okay, now I will introduce the key design of this test suite. Because if you want to run our test suite against your implementation, you'll have to be careful about this part. Firstly, I will introduce how our test suite works with the Windows side. The left side is our test suite, which includes two components. One is the SAT adapter, which means we will use this component to control the SAT. And the lower part is our protocol adapter, which is similar to other test suites. And the right side is the Windows SAT. We will drive the Windows task scheduler component to invoke the scripts which is pre-configured on the SAT. And those scripts will invoke the SMB's Windows services. Then the services will send the request and receive response. So the first step is our test suite will invoke the scripts. You can find those two scripts in our test suite. And this PowerShell scripts will invoke the Windows task scheduler remotely. Then the task scheduler will invoke the Windows shell scripts. Then the Windows shell scripts will invoke the SMB applications or the SMB services. The service will send the first request, SMB request, to our test suite. Now our test suite receives the request message. Our test suite will respond the related response messages. So when you trying to deploy our test suite against your implementation, you must change this part. You can change them to the manual way. That means you can use the interactive adapter. When you start the test cases, there will be a message box to promote you to do the related operations on your system. And also you can change our PowerShell scripts. You can change them to talk with your system from TCP transport or UDP transport or even HTTP transport. Then you have to change this part as well, because in your system, you may not have the Windows task scheduler. So you can configure some services or executable files which listens and interactive with the SAT control adapter. Okay, I will talk about the test scenarios for this test suite. If you open the code script of this test suite, which used to generate model-based test cases, you can see some action sequence like this. And this script is for the first scenario, connect to the share. Then if you use the Spec Explorer to explore this scenario, you will see the state diagram like this. You can see for each action, you can find each action from this diagram. For example, you can see the process session setup NX action after the state 6. Then this scenario will generate the test like this. This is the first action. Our test suite will trigger the SAT to send the first request message, which should be SMB com negotiate request. Then our test suite will respond the corresponding response message. And in our test suite, as I have already stated, it's a synchronized model. So we just combine the receiving request message and sending the response message together into a single method. So this is step 1, this is step 2. So this is 3, 4, and 5. In the last step, our test cases typically will terminate it's a cleanup method for the SAT, which typically used to clean up all the sessions and TCP connections from your system. Okay. So for SMB protocol, there is not hard requirements for the message sequence. For example, if you want to write a file to the remote server, there's no hard requirement for this kind of message sequence. Maybe the only requirement is you have to do the negotiate first, then session setup, then the tree connection. But after that, you can do any sequence for those messages. So if you want our test suite to run against your specific message sequence, you can just change the code script. This is our default setup for this scenario. And after you change the sequence, for example, you switch the query and write action, then you can regenerate the scenario. Then you can generate the test cases like this message sequence. The query can be after the write action. Maybe Chiron's demo will cover this part. Okay, Chiron. Okay, let's see Chiron's demo.
Needing your mic.
Okay.
And which machine is this? This is also device.
Okay.
Okay, so we have this client test suite, SMB server client test suite. Till now, our focus was that, we'll test only, like we used to write test suite to test only server. For the first time, I suppose, we have written a test suite to test the client endpoint. Generally, we used to test, the server endpoint. Like, we have a synthetic client, initiating a request, getting a response, and validating it. In this case, we will trigger the SUT or the client to send a request to us. He will initiate a request, will not initiate a request. We'll just validate the request, and we will frame a response and we'll send it to the client. Okay, so on this machine, where our test suite is installed right now, it's behaving as a server. We don't have file sharing services installed on this server, but our test suite will act as a synthetic server here. So I'll show how we have created that. But before that, let me walk down through the code. And so the same thing. Now we have taken modeling approach, and so if you see, like in the scenarios right now, so we always say we are processing the request that we are getting from from the SUD. We are not triggering a request. Like if you see all the message signatures, like they are process session setup and X. So we are getting a request from the client, and we are processing it, and we are replying it to the client, and then we'll get a next request, we'll process it, and we'll send the reply to the client. So we are acting as a synthetic server out here. So okay, and so how we are doing it, as Shalu said, I'll just show you our remote server, like Windows Server, where we have done all the configurations. Okay, so I'll come to the server part. So what we do as a part of this test suite is, first we invoke a remote task on the server, and as a part of that task, we ask server to do some operation or that will send some packet to our server, like the other endpoint. So what we are doing is here, like I'll just comment this for non-Windows. So we are scheduling a task, and we are passing an operation, like whether you want to connect, whether you want to do a read operation or write operation, and based on that task will perform an operation. Now I'll tell you how we have done the setup on the other endpoint. So we have a task scheduler here, and we have all these tasks pre-configured. And what we do as a part of these tasks, like whenever a request comes for this task, we invoke this file. Okay, now let's see what this file is doing. So this file is in C drive, SMB triggers, and let's see what connect server is doing. So what connect server will do, connect server will try to open a file on the machine where test suite is installed. So what we are doing, we are asking the other endpoint to send a file open command or file write command, and our synthetic server will get that command and will process it and will send a reply. And so right now file sharing services are not there, so our synthetic test suite is listening on 445 port. So we'll receive all the requests and we will process it. So like this is for open text file. So I'll just show you the demo that how it will go. So we have all the tasks here. Now I'll go to the machine on which test suite is installed, and I'll just debug it to show in detail how we are doing it. So at this point, we'll send a command to the other endpoint to run that task and perform an operation like write operation or connect operation or open operation. Based on that, we'll get a request from the server, and if you see this call, we'll process that request. We'll do a negotiation, and all the authentication, like whether it's Kerberos or NTLM, we'll take care of that. Whatever token we have to compute, we'll do using our own synthetic libraries. Just give me a minute. Okay, I think I need to change one thing. Just give me a minute. I'm not sure. Okay. So let me try again. There was one problem. Okay, so this test case got passed, and I'll show the entire traffic. So we got all these messages from the client. We processed it, and we replied to the client. So that way, we're acting as synthetic server, and we are validating the client endpoint whether all the messages are coming correctly or not, and all the formats are correct or not. So any queries till now, and we have limited test cases because most of the requirements we cover as a part of testing the server endpoint. Like this is a client test suite. We have a SMB server test suite also. So most of the requirement we cover as a part of SMB server test suites. There are some requirements that we don't cover as a part of SMB server test suites, and those requirements will be covered as a part of client test suite. So there are not many requirements, and we have limited scenarios as such, but they can be expanded. It all depends. So we have close to 42 test cases right now. Okay, and I'll show how to modify, because what we saw, we ran this client test suite, we tested this against non-Windows server, and what we saw was we were expecting the response, the request in this format, in this sequence, I will say. It should be negotiate, then session setup, then tree connect, then create, write, and close, and then okay, it's up till close. But when we tested against non-Windows, what we saw was instead of create, we were getting an open request that says, okay, if it doesn't exist, create it. As far as Windows clients are concerned, open is deprecated. So Windows client, they don't send open as such. They always send create, but non-Windows server can send that, and we have seen that they are sending it as such. So we'll test this scenario against non-Windows, and it will fail because we know it will send open. Then I will let you know how to fix that problem, because it's a synthetic server. It can get any request packet, but since it's a synthetic, it will not process all the packets. So you have to change that sequence in model. So maybe Nick, you can show that a non-Windows setup first. So to show you non-Windows setup first, because we'll run these test cases against non-Windows now. Yeah. So non-Windows setup first. Yeah. Yeah, I don't have PuTTY, but we can go to this machine, right? Can we do MSTC? Can we do MSTC? Will the remoting work?
No.
I can do one thing.
Well, Can you go to the VM where you have the test suite installed? It has PuTTY.
Do we need PuTTY as such?
You can't RDP it.
Oh, okay.
So just go to the test suite because we know we have PuTTY installed.
This is the host, right?
Yeah.
That's it. So we have.
Just double click on Fedora.
You will not be able to use mouse, right?
Yes, okay.
Oh, that's okay.
Yeah, that's fine. Okay, so to simulate what we did with Windows, in the default configuration, we have the control adapter, which is titled Invoke Remote Command, that will go off and ask the task scheduler on the remote system to go ahead and run a predefined task. For what we did to get around that on Linux is we actually modify the invoke command to be an SSH command. We then use the AT scheduler on Linux to run one of a bunch of predefined script files we've created. So can you pull up your invoke command?
Yeah.
So the invoke command will just go off and just issue an SSH command with, we use PuTTY. PuTTY lets you actually specify a password on the command line, so you don't need to set up SSH keys or anything. And it will invoke a script that's sitting in the root directory of root called invoke cmd.sh. And this parameter right here will either be like connect, share, write, next. It'll be whatever operation you want to perform. The script that kind of drives all this on the other end simply says, well, what's the operation? Let's go invoke. It's basically a large case statement. It says, let's go invoke the script that does whatever. We tested with both the SMB client and sifs.ko. So you actually mount the remote share and then go off and do a cat on a file if you can do a read. And both of those actually worked. So where are we at here? Okay.
Should I execute?
Okay.
Last one. Yeah, this one.
So.
Not come down.
I don't know. Okay. Let's do this. Alt F7, Alt F8. We got one huge. We're going the wrong direction. Here we go.
You can scroll this maybe. You scroll this.
Well, hang on. I'm just trying to shrink the window size. There we go.
Okay.
Okay, so okay. And so basically, it's just a large case statement. It'll go off and invoke a script-specific one. So if we kind of and basically, if you kind of come down to about this area here, we actually invoke the SMB client command to go off and perform a get operation on a file on the server that actually generates the correct sequence of commands that the synthetic server is looking for. So
Right.
we'll actually go off and
Right.
run it.
So I'll go up and run against non-Windows now. So we have to. So I change this invoke remote operation and I change it to plink now. And I'll go and change this to the non-Windows server. Let's try connect first. It's negotiate only, right? Why? No. So we can see all the packets, and the packets are initiated by Fedora machine, not by us. Where is the tank?
Yeah.
I'm not sure where it's stuck. Come on. It's stuck somewhere. It should not take this much time ideally, but anyways, we are able to see that we got negotiate and session setup requests, and we are able to reply to those requests, and the other endpoint is accepting it. It's stuck somewhere. Okay. I will just abort it, and I will just show you. This will pass. I'll just show you one more test case where we are expecting failure. Bear with me. Let me reopen the code again. Okay. So let's see. So we tested connect. Let's see the behavior of write. Okay. So here the problem is that we're expecting, like, if we go back to our model, we're expecting a create from the other endpoint, but we are getting open. Like, let me go to the snip. We are getting open from the server, like from the other endpoint, and we are not expecting that because we are synthetic server. So we are not able to process that command because we are not expecting it. So what we have to do for this, and that's the best part with model, that you don't have to worry about adapter and all other layers. Just comment this. This is our scenario. Just comment this. We don't want create. We want open. Okay, and this is the test case. It should come back. Sorry. Just close this. So now we are saying, okay, do an open, expect an open now, not create. I'm not sure what's happened to this now. expecting this to come here, but it's not showing up. It's not showing up right. Right, file test. Oh, okay. I don't have any filter also. It's not coming. Let me do one thing. Sorry? No. It doesn't have to do anything with script. Which one? No, it's not a problem with script. Let me do one thing. Now it came. Okay, so I'll generate test code from this. Okay, and now this also came. Okay, now, so I've changed my our sequence now. We're expecting an open now. So it passed this time because we got open, and then after open, okay, again, we are expecting write, we are getting write. So that way, if you want to change the implementation on the test suite side, it's quite easy to do that with modeling approach. You just have to play with these sequences, and things will work fine. Just generate test cases again. So any queries as such about the approach or test suite?
Last point, can you pull up Linux real quick?
Sorry?
Pull up Linux real quick.
Okay.
Where is it? One last point that we make is the synthetic server is testing a specific sequence of packets, so it's doing a testing write next. It'll test up to the write next. It doesn't care about the session teardown. So usually after it's validated everything, it just basically shuts itself down. So you might see, depending on how much detail you log in your own application, you might see broken pipe. That's actually not an error on the Linux side. It's simply because our synthetic client simply just said, I did everything I need to do to complete the test. So just heads up on that.
Right.
So that's it.
That's it.
Any other questions? Thanks. Well, this is one of the tests that's available to you in the office. If you're in the lab offices, if you're interested in running the VM, you can do that. So just as Tarun and Nick have shown you the examples here, Windows to Windows or Windows to non-Windows, we can certainly go over that with you offline if you have any questions about the client test suite validation. The other method of client validation you may have seen at the AD Plugfest, where we validated the process of joining a domain with using a netmon analysis, post-capture analysis. That's it for this session. The next session we'll hold at 2 o'clock will be here with the protocol documentation team. They're interested in meeting with you, as well as at 3 o'clock we have the file services product team is back. The SW's team, Tom Talby, those folks, Dave Cruz will be here. So if you have some specific questions, we also have a couple folks who asked some specific branch cache questions. So we have some specific people to meet with them. So that's coming at 3. Yes?
Is that just going to be sort of free-form drop questions, and you want us to reseed you?
Yeah, if you have some questions, let us know, but we want to capture those if there's something we need to follow up on. But it would be just a general discussion. David and those guys will be here, Tom, to answer your questions here in this room at 3 o'clock.